Okay, let's look at lesson 7. How do I find the perimeter and area of complex figures? This is probably going to be the hardest essential question of this unit, but I know we'll get through it. Let's take a look at workbook page 65. First, we're going to find the area of this triangle. So let's think about the formula for finding area of a triangle. We have to do 1/2 base times height. So I would have to do 1/2 times the base times the height. Well, 1/2 times 4 is 2, right? Because we're talking about half of 4. And then 2 times 4 is going to give me 8. So the area of the triangle is 6 square centimeters. Next, I'm going to find the area of this rectangle. So of course, length times width, 6 times 4, that's going to give me 24 square centimeters. And then we're going to find the area of this complex figure. Ladies and gentlemen, a complex figure is, well, just that. It's a geometric figure made up of smaller geometric shapes, ones that you're already very familiar with, such as triangles and rectangles, squares, parallelograms, trapezoids. All the ones that we have found the area of so far, you may come across them in a complex figure. It's very simple to find the area of a complex figure once you have decomposed it. Decomposing means that you break the figure up into, or break it down into your familiar shapes. Once you have the area of all of those shapes, just add them up and there's your total area of the complex figure. So all I would have to do is take the area of the triangle, the 8, combine it with the area of the rectangle, which is 24, and that is going to give me 32 square centimeters. Now, the ones that you see on workbook page 66 are a little bit more complicated, so I thought maybe we would do some of those together and you could do some of the less complicated ones on your own. I think number 9 is especially tricky, so we're definitely going to get to that one. And I think I might actually do area first, and then we can do perimeter later. Remember, perimeter is when you just add up all those sides. Let's see. If I were to break this up, I guess there's actually a couple ways to break it up. Sometimes it's very obvious. Oh, that's a rectangle, that's a triangle. And sometimes you might see that, you have different ways that you can decompose this figure. For example, you may want to break it up this way. Here you have a square and 2 rectangles. Or maybe you want 2 squares. Or maybe you would rather break it up with, we'll make that a square here, and maybe a little teeny rectangle on the side up here. So there's a couple different ways that you could break this figure up. I guess we can go with this way since we just figured this out. I'm going to start with, let's see, we have 2 rectangles. So I'm going to call one rectangle 1, the other one's rectangle 2, and then we have a square. So I'm going to call this one rectangle 1. And rectangle 1's not too bad. We just have to do length times width to find the area. Well, it looks like our length is 3 and our width is 1, so we'd have to do 3 times 1, which is 3. Pretty simple. So we've already gotten the area of one rectangle. Now let's take a look at the next rectangle. The next rectangle, we'll call this one rectangle 2. This one might be a little bit more complicated. First, you can probably pick out that we have a length of 5, so that's nice. But now the hard part is this width. We need to figure out the width of that rectangle. And notice that the width, since it doesn't have a measurement there, we can use some of the other measurements to help us. Keep in mind that because the width is a horizontal length. Horizontal means it goes from left to right. It doesn't go up and down. It goes left to right. Since it's a horizontal measurement, I'm going to look to some of the other horizontal measurements to help me. Take a look at the top section. From here to here is 3 yards. Well, you kind of already know that this little section right here is 1 yard, because That's what it is down here. You know that both sides of that little skinny rectangle are going to be 1 yard. That's going to help us to figure out that this section then must be 2, because 1 plus 2 gives us our total of 3 yards that we have here. That means down here, this is also going to be 2. If you have 2 at the top, you're going to have 2 at the bottom. And we now have our width, 5 times 2. And that's going to give us 10 square yards. So far we are on a roll. We have gotten the 2 rectangles. I'm just going to erase some of this stuff, make it looks a little complicated. All that's left is the square. And let's see, we need to know, well, what one of the sides is, right? If we know one side, then we know all the sides. In this case, I know that this whole length here is 4. The reason I know it's 4 is because this whole length here is 4. We have 2 right here, plus 2 more, and there's our total of 4. So I know one side is 4, meaning all the sides are 4. 4 times 4 is 16, so we have 16 square yards. Now all that's left is to add them all up, and we will have our total area. So 10 plus 16 plus the other 3, that's going to give us 29 square yards. There's other ways you could have broken this up and found the area. No matter which way you go about it, no matter how you break it up, you are going to get an area of 29 square yards. Keep in mind, if you're looking for horizontal measurements, look to other horizontal lines to help you. If you're looking for a vertical measurement, look to other vertical lines to help you. Now let's do the perimeter. Now we have to add up all the sides. And since you have a lot of different sides, I think it helps to trace your way around and make sure you're not missing anything. So we have 3 plus 1 plus 6 plus 4. Remember, we figured out that that was 4. Plus, of course, another 4, because it's a square. All those sides are 4. Plus 2 plus 5. So notice I traced all the way around and I made sure that I had every single measurement. And you can add them up as you go along. When you add up all of your sides, you're going to get a perimeter of 28 yards. Alright, we are going to move on to number 10. I'm going to give myself some space because I'm going to need to write out some of the work. Notice that I have been writing out all of the things that I'm multiplying and all the things I'm doing to find the area of every little shape, because it's important to keep track of all your information so you know what you have to add up later. Okay, number 10. Let's see, I could break this up a couple different ways. One way is, it's kind of obvious, it's done for us, is to break it up into 2 trapezoids. You can see that we have 2 right trapezoids. Another option might be to break it up using a rectangle and a triangle. Doesn't matter to me. I think I like the idea of the 2 trapezoids because it does kind of look like it's already been broken up for us that way. So, and if you notice, it looks like both trapezoids are exactly the same. So if I know the area of one trapezoid, I'm going to know the area of the other one as well. I'm going to start with maybe the bottom trapezoid. I know that I need my height and I need my 2 bases. So in this case, I have, let's see, a base of 2 and a base of 5. And my height, well, now I need to know how tall this trapezoid is. Notice I'm not using the slanted side. I can see that this figure was divided right down the center. And if this whole height is 8, I know that if I divide it in the center, 4 must be the height of the top trapezoid and 4 must be the height of the bottom trapezoid. So now it's going to look like this. Let's see, 1/2 times 4, or half of 4, is 2. And uh-oh, I forgot to do what's in the parentheses first, my mistake. 2 plus 5 is 7, and now I can do the multiplication. Half of 4 is 2. 2 times 7 is 14. So the area of the one trapezoid, remember that's only one trapezoid, is 14. So the area of this one is going to be 14, which means the area of this one's 14, and if I put that together, that's a total area of 28 square feet. Now remember, there's multiple ways you could go about this. And if one way isn't quite working for you, feel free to switch. It's always okay to change how you break a figure up. Maybe I will go back to that triangle and that rectangle. First, I might start with the rectangle. For the rectangle, I have to do length times width. So here's my length of 8, my width of 2. 8 times 2 is 16. Then I have to do the triangle. So it looks like I have a base of 8 still, right? Because it's the same as the other side of the rectangle. No matter which way you look at it, the length of the rectangle is 8, causing the base of this triangle to be 8. And now I need, so 1/2 base, and now I need the height of the triangle. So now I'm trying to figure out, let's just erase a little bit. Oops. Do some erasing. Now I need to figure out this section right here. If you notice, it says 5 feet, but that's for the whole part from here to here, from this bottom of the rectangle to the top of the triangle. So I don't need all 5, I just need this section. I'm going to have to do some subtraction to figure out this section right here. If you notice, that is a horizontal line, which means I can use other horizontal lines to help me. I think I'm going to use this horizontal line to help me. I know from here to here is 2, which means from here to here is 2, and that means that this must be 3 here, because 2 plus 3 gives us our total length of 5. So 3 is our missing height. So let's see, 1/2 times 8 is 4, because 1/2 of 8 is 4. 4 times 3 is 12. And now we have the area of the rectangle and the triangle. If I put them together, 16 plus 12, there's our 28 still. So no matter how you go about doing this, you're going to get the same area both ways. Now it's time to do the perimeter, and that's going to be a little bit easier. Remember, it helps to trace your way around. 8 plus 2 plus 5 plus 5. Notice I didn't use those 5s before when I was finding the area, but I do need those 2 slanted sides for the perimeter. And let's see. Oops, went backwards. Plus, the 2 more. Don't forget the 2 over here. So 8 plus 2 plus 5 plus 5 plus 2. That would give us 22 feet. And I just realized I had accidentally erased that one before. I think this was 28 if I remember correctly. 28 square feet for the area. In addition to finding the area of complex figures, you may also see, you could say complex figures, where you have to find the area of the shaded part of a certain figure. And if you look carefully here in number 14, you can see that we actually have 2 different triangles. We have a little triangle that's white right here, but then we also have this big triangle that includes the white one and the orange section as well. Whenever you're being asked to find the area of a shaded part, I think it helps to find the area of the big shape first. In this case, I might find the area of the big triangle, and then I'll find the area of the smaller shape, and I can subtract out the smaller shape, the smaller triangle, and get the area of the shaded section. So I think it helps to use subtraction here. Let's start with the big triangle. First I need that 1/2 times the base. Well, let's see, the base here is going to be this section right here, 2 and 4. Oh, well, together that's 6. My base is 6 because 2 plus 4 more is 6. Now I need the height, so that's from here to here. Well, that's 3 plus 5 more, so that's going to be a height of 8. And now I can put it all together. Half of 6, or 1/2 times 6 is 3. 3 times 8 is 24. So the area of the big triangle is 24 square centimeters. Now let's focus on the smaller triangle. Let's focus on the white one. And let's see. The white triangle's right here. Notice the base is the same. Let's see, I'm going to write little triangle. The base is the same. The base is still 6. The height is different though. The height is only 3. And half of 6 is 3. 3 times 3 gives us 9. So now we have the area of the big triangle and we have the area of the small triangle. What I could do is subtract them. I can take the area of the big triangle and subtract out the area of the small triangle, get rid of it, and all that would be left would be that shaded part that we're trying to find the area of. So 24 minus 9. That'll give us 15 square centimeters. Okay, so here are the takeaways. First, a complex figure is a figure made by combining simple geometric figures, such as rectangles and triangles and all of that. To find the area of a complex figure, first break the figure up into familiar shapes. That's where you decompose it. Then identify the missing measurements needed. And then find the area of each of those small shapes and add up all the areas to obtain the total area of the complex figure. And this part is really very, very important here. When finding missing measurements, so when finding missing vertical measurements, if you're missing a vertical measurement, look to other vertical measurements to help you. When finding missing horizontal measurements, look to other horizontal measurements in the figure to help you. So you may have to do some subtraction or maybe some addition to figure out those missing measurements.